On June 1st, 2025, at 11:47 p.m. Moscow time, something extraordinary happened in the skies over Russia. Not in Ukraine, not near the front lines. Deep inside Russian territory, over 1,000 kilometers from contested ground, 117 small, nearly silent drones rose from concealment. They were FPV drones, first-person view quadcopters, modified racing drones retrofitted with explosives, each costing approximately $400. Within hours, these humble machines would accomplish what Western military analysts said was impossible. They damaged or destroyed 41 strategic aircraft, including some of Russia's most advanced long-range bombers. They shattered the myth that Russia's heartland was untouchable. What makes this moment extraordinary isn't just the tactical victory, it's the strategy behind it. Ukraine didn't rush into this offensive. For 3 years, while Russia poured thousands of drones into Ukrainian airspace, waves of Iranian Shahed drones, kamikaze FPVs, surveillance platforms, Ukraine waited, watched, adapted, it built. While Western observers debated whether Ukraine could win, Ukrainian engineers were engineering a future where cost-effectiveness, innovation, and technological agility would remake modern warfare. This is the story of how a nation under siege became a drone superpower. It's about the engineers working in basements and makeshift factories, the drone pilots flying by night with thermal imaging, the mathematicians gamifying warfare to optimize kills, and the politicians who understood that the future battlefield wouldn't be decided by tank columns, but by invisible swarms of autonomous machines. Most importantly, it's about a strategic choice. Ukraine chose patience over panic. It chose to let Russia reveal its capabilities, its vulnerabilities, its patterns. And then, when Russia believed it had achieved total drone dominance, Ukraine struck, not with a desperate counteroffensive, but with a demonstration of innovation so complete that it forced the world to rewrite everything it believed about 21st century warfare. From deep inside Russian air bases to the laboratories of Kyiv, from AI algorithms processing thermal imagery to satellites tracking Russian supply lines, Ukraine executed a long-game strategy that proves one undeniable truth. In modern warfare, the side that innovates fastest doesn't win with numbers. It wins by being smarter. This is what happened when Ukraine turned the tables. To understand Operation Spiderweb, you must first understand the battlefield that created it. In February 2022, when Russia launched its full-scale invasion, Ukraine faced an enemy with overwhelming conventional advantages. Russia possessed air superiority, numerical superiority in every category of traditional weapons, and 3 decades of post-Soviet military doctrine, refined through operations in Georgia, Syria, and Crimea. Ukraine possessed something different, desperation married to innovation. In the first weeks of the war, Ukrainian forces faced catastrophic losses. Russian aircraft dominated the skies. Russian artillery outgunned Ukrainian positions. Russian missiles struck with impunity. Military strategists in Washington, London, and Brussels quietly accepted that Ukraine would fall within weeks. The consensus was grim. This was not a winnable conflict, but the conflict didn't end. Instead, it transformed. By mid-2022, Ukrainian commanders realized something profound. They didn't have to match Russia's tank for tank, fighter jet for fighter jet. They couldn't. Instead, they could innovate in a domain where Russia had invested billions but never truly dominated: unmanned systems. Initially, Ukraine's drone fleet was crude, older commercial drones retrofitted with explosives, surveillance quadcopters borrowed from construction sites. But by late 2022, a crucial shift occurred. Young engineers, many in their 20s and 30s, began experimenting with first-person view racing drones. These were machines originally designed for hobby racing, operated by people wearing electronic goggles, flying beyond line of sight in real time. They were inherently precise, inherently controllable, inherently devastating. More importantly, they were cheap. A single FPV drone cost $500 to $800 to manufacture. A Russian main battle tank cost $8 to $10 million. The economics were absurd. One cheap machine could destroy one expensive machine, and Ukraine could afford to manufacture thousands. By 2023, Ukraine was producing tens of thousands of FPV drones monthly. By 2024, that number accelerated exponentially. The data was staggering. By March 2024, Ukrainian forces were launching approximately 250 FPV drones daily. By August 2024, That figure reached 1,000 to 1,200 per day. By some months, the daily average climbed to 30,000. Russia responded with its own drone offensive. The Shahed, an Iranian-designed long-range kamikaze drone, became the workhorse of Russian aerial assault. From September 2024 through February 2025, Russia launched more than 1,000 Shahed drones monthly against Ukrainian targets. On November 26, 2024, Russia achieved a terrifying milestone, launching 188 drones in a single night against Ukrainian cities. The conventional analysis suggested Russia was winning this attrition war. They had more drones in production. They had Iranian supply chains. They had electronic warfare systems adapted from decades of Soviet-era research. They had geography, with Russia's territory vast and seemingly remote from Ukrainian reach. But Ukrainian military planners saw something different. They recognized that Russia was making predictable decisions, operating from known bases, following established logistics patterns. And they understood that Russia's confidence in its strategic depth, the belief that the interior of Russia was militarily untouchable, was a vulnerability. For 18 months, while Russia rained drones on Ukrainian cities, while Western observers focused on the grinding positional warfare along the front lines, Ukraine executed a hidden strategy. They built domestic drone production capacity. They developed long-range strike drones, unmanned systems capable of flying over 1,000 kilometers, reaching deep into Russian territory. They experimented with artificial intelligence, creating systems that could identify targets, navigate in GPS-denied environments, and adapt to electronic warfare in real time. Most crucially, they gathered intelligence. Ukrainian military intelligence worked with signals analysts and satellite imagery specialists to map Russian air defenses, identify gaps in electronic warfare coverage, and document the precise locations of Russia's most strategically important aircraft. By early 2025, Ukraine had positioned itself not as a desperate nation defending against overwhelming force, but as a technological power preparing for something unprecedented. They had $450 million in defense contracts issued to 76 domestic drone manufacturers. They claimed the capacity to produce 4 million drones annually, a number that seemed almost mythical to Western observers, yet reflected Ukraine's industrial mobilization. More than just production, Ukraine had achieved something qualitative. Through companies like Vyry and designer collective Aerorozvidka, Ukraine had created drone ecosystems. The Vyry fleet of long-range octocopters, the Aerorozvidka R-18, an 8-rotor platform capable of delivering 5-kilogram payloads while flying 40 minutes at night using thermal imaging. Custom-built interceptor drones designed specifically to hunt Russian reconnaissance platforms. The technological development wasn't limited to hardware. Ukrainian software engineers and AI specialists, many working with companies like Palantir, created targeting systems that could process thermal imagery, identify enemy positions, and guide autonomous systems to targets with minimal human intervention. This was revolutionary. It meant that operators didn't need constant GPS signals. They didn't need radio links that could be jammed. These drones could see, think, and decide independently. Ukrainian military leadership understood the implications. Former Commander-in-Chief Valery Zaluzhny, the architect of Ukraine's drone doctrine, articulated it plainly in April 2025. The Russian-Ukrainian war has completely changed the nature of warfare. Wars of the future will be won by countries that focus resources on drones, electronic warfare, and artificial intelligence. Victory now depends entirely on the ability to outpace the enemy in technological development. This wasn't bravado. It was strategic doctrine. Ukraine had decided that it could not win through attrition, but it could win through innovation. By June 2025, Ukraine had assembled the components for an operation that would test every theoretical advantage it had developed. They had intelligence on Russian bomber bases. They had drones capable of long-range strikes. They had AI systems to guide them. They had operatives inside Russia who could launch these platforms from territory Russia believed was secure. What they were preparing for was called Operation Spiderweb, and it would prove that Ukraine's patience, its willingness to absorb Russian drone strikes for 18 months while building capacity, had been strategic genius. June 1, 2025 began as an ordinary night in Moscow. President Vladimir Putin was in his secure compound. Russian military commanders at the General Staff believed their border was secure. Across 5 Russian air bases, Belaya, Diaghilevo, Ivanovo-Severny, Olenya, and Ukrainka, Russia's most strategically significant aircraft sat on the tarmac. Tu-95 strategic bombers capable of carrying nuclear weapons, Tu-22M strike aircraft, 50 airborne early warning platforms, the eyes of Russia's long-range operations. These weren't arbitrary targets. The Tu-95 and Tu-22M represent Russia's ability to project power beyond its borders. Each aircraft costs hundreds of millions of dollars. The A-50 is irreplaceable. To damage or destroy any significant portion of these fleets would be to fundamentally degrade Russia's strategic capabilities. Ukraine's plan was breathtaking in its audacity and precision. Weeks before, SBU, Ukraine's security service, had infiltrated FPV drones into Russian territory, not through the air, which would have been detected, but through ground infiltration. Operatives drove trucks into Russia, positioned them within 20 kilometers of the target air bases, and concealed them. Inside these trucks were the components for launching over 100 FPV drones, small quadcopters, flight batteries, targeting systems, communications equipment. At 11:47 p.m. Moscow time, the operation commenced. 117 drones rose from concealment. They flew in coordinated waves, approaching the 5 air bases simultaneously. They were piloted by experienced drone operators in Ukraine, receiving real-time video feeds through encrypted communications. Each drone was equipped with thermal imaging, allowing pilots to navigate the darkened landscape and identify their targets with precision. The drones descended on the air bases like mechanical wasps. Boom, boom, boom. Each impact a direct hit. Each explosion, another American-supplied aircraft disabled or destroyed. The Tu-95s, machines worth $500 million each, capable of striking American cities, able to carry Russia's strategic nuclear arsenal, exploded in succession. Within hours, Ukrainian military officials announced the results: 41 aircraft damaged or destroyed across 5 bases. That figure included multiple Tu-95s and Tu-22Ms, at least 4 A-50 early warning aircraft, which are so specialized that Russia cannot easily replace them. Ukrainian officials claimed that roughly 34% of Russia's strategic cruise missile-carrying bomber force had been rendered inoperable in a single night. To comprehend this moment, you must understand what this meant strategically. Russia's strategy throughout the war had relied on the belief that it could strike Ukraine from a distance, launching cruise missiles from bombers flying deep within Russian territory. These aircraft couldn't be reached by Ukrainian air defenses. They were outside the battlefield. They were untouchable. Operation Spiderweb proved that nothing inside Russia was untouchable anymore. The psychological impact was immediate and global. Russian social media erupted in panic. Military bloggers and intelligence analysts published frantic assessments. Western think tanks scrambled to understand how Ukraine had executed such a precise, coordinated, long-range strike. Russian officials blamed electronic warfare interference, insufficient air defenses, and operational security failures. But the real issue was more fundamental. Ukraine had demonstrated technological sophistication, strategic planning, and operational capability at a level that inverted the conventional understanding of the conflict. This wasn't a desperate nation barely surviving. This was a technologically advanced military executing precision operations deep inside enemy territory. Within hours, Russia began retaliating. On June 3rd, Russian forces launched a devastating counterstrike, nearly 500 drones and missiles against Ukrainian targets. It was one of the largest attacks of the entire war. Ukrainian air defense systems worked overtime, engaging the incoming weapons. Civilian casualties mounted. Power stations were damaged. The retaliation was ferocious, yet the strategic equation had shifted. Russia's retaliation was reactive, desperate even. Ukraine had achieved the initiative. More importantly, Ukraine had demonstrated that it possessed an asymmetric capability that Russia could not adequately defend against the ability to strike Russian territory with precision long-range systems. Over the following weeks, the implications became clearer. If Ukraine could reach strategic aircraft at Olenya Air Base, nearly 1,500 kilometers from the front line, what else could it reach? Military planners worldwide began calculating. Ukrainian drones could potentially reach Moscow, St. Petersburg, any significant target within Russia's European territory. This wasn't just a military problem for Russia. It was a strategic problem. Russia's entire wartime strategy depended on the ability to wage industrial-scale warfare without suffering significant damage on the home front. The belief that Moscow was safe, that Russia's cities were beyond Ukrainian reach, that the conflict would be decided by grinding attrition in the muddy trenches of eastern Ukraine, that belief had been shattered. But Operation Spiderweb represented more than just a tactical victory. It represented the culmination of Ukraine's strategic bet. For 18 months, while Russia launched thousands of drones against Ukrainian infrastructure, while Russian missiles struck power stations and apartment buildings, Ukraine absorbed the punishment. Ukrainian civilians suffered. The economy sustained enormous damage. Yet during that same period, Ukraine was building. Hundreds of small companies, many operating from basements and repurposed warehouses, manufactured drones. Engineers worked through the night designing AI systems. Programmers developed targeting software. Military logistics specialists figured out how to mass-produce weapons of war that cost less than a used car but could destroy military equipment worth millions. The question that Ukrainian strategists had posed to themselves was profound. Could we win through innovation? Could we compensate for Russia's numerical and conventional advantages through technological superiority? Could we turn the asymmetry of modern warfare, where cheap, expendable drones defeat expensive, irreplaceable platforms, into a strategic advantage? Operation Spiderweb answered yes. The aftermath of Operation Spiderweb rippled across military establishments worldwide. In the Pentagon, strategists reassessed doctrine. In European capitals, defense ministers convened emergency meetings. In Moscow, the Kremlin faced a profound strategic crisis. Most significantly, Operation Spiderweb forced a re-evaluation of nuclear deterrence. Russia's nuclear strategy relies on the ability to deliver nuclear weapons through long-range bombers. If those bombers could be destroyed while sitting on protected air bases inside Russian territory, what did that say about Russia's nuclear deterrent? Within months, Russia quietly revised its nuclear doctrine, lowering the threshold for nuclear weapons use, an acknowledgement of how thoroughly Operation Spiderweb had undermined Russia's strategic confidence. The implications were staggering. If Russia could no longer guarantee the survivability of its strategic bombers, and if its air defense systems had proven inadequate against Ukrainian drone swarms, then the entire edifice of Russian nuclear deterrence, built on the premise of invulnerability, had been compromised. Russian military analysts began frantically modeling scenarios where Ukrainian long-range drones might strike deeper into Russian territory, potentially reaching command bunkers, communication nodes, and other critical infrastructure. The psychological impact on Russian leadership was profound. For decades, Russia had relied on the assumption that its vast geography, its distance from NATO, and its early warning systems provided security. Operation Spiderweb shattered that illusion, but the most immediate impact was on the ground. Throughout the summer and fall of 2025, Ukraine accelerated its drone operations with systematic precision, long-range strikes against Russian oil refineries, precision attacks on ammunition depots, coordinated strikes on air defense positions. The numbers were staggering. By August 2025, Ukraine conducted additional long-range operations that reportedly created fuel shortages across Russia, forcing some regions to introduce gasoline rationing and triggering record price hikes. The economic impact on Russia was significant, perhaps more significant than the military losses. Ukraine's strategy had evolved beyond simply destroying enemy equipment. It was waging sustained economic warfare, strangling Russian logistics networks, degrading Russia's refinery capacity, making the war structurally unsustainable for the Russian state. Between June and September 2025, Russian energy companies reported production losses of roughly 30%. By October 2025, some Russian regions experienced gasoline prices that tripled from their pre-summer levels. This wasn't abstract military analysis. This was economic pressure cascading through Russian civilian life, affecting ordinary citizens and straining the state's fiscal capacity to sustain the war effort. More critically, Ukraine's strikes on ammunition production facilities created what Russian military officials privately acknowledged was a catastrophic supply chain disruption. By September 2025, Russian military units reported ammunition rationing at the front lines. The situation deteriorated to the point where Russian artillery, which had previously maintained rates of fire of hundreds of rounds daily, was restricted to dozens. This fundamentally altered the tactical situation along the entire front line. Without overwhelming firepower, Russia's grinding attrition strategy became impossible to execute. Meanwhile, domestically, Ukraine accelerated drone production even further. The data was remarkable. By August 2025, Ukrainian military intelligence reported that Ukraine was producing 200,000 FPV drones monthly. That's a rate of production that would yield over 2 million annually, approaching the 4 million claimed capacity. By comparison, Russia's production rates, while significant, never reached comparable scale. More troubling for Russian planners was the trajectory. Ukrainian production was accelerating. New factories were coming online. Supply chains were consolidating. By November 2025, some analysts projected Ukrainian production could reach 300,000 units monthly by early 2026, but raw production numbers were only part of the story. The real revolution was in quality and specialization. Early in the war, Ukraine produced mainly FPV drones, simple, affordable, effective, but ultimately single-purpose machines. By mid-2025, Ukrainian manufacturers had diversified into specialized platforms, loitering munitions designed specifically for armor targeting, reconnaissance drones equipped with advanced synthetic aperture radar, interceptor drones designed to collide with Russian aircraft, electronic warfare drones that could jam Russian communications, counter-drone systems that could identify and engage enemy unmanned platforms. This specialization represented a fundamental shift in how Ukraine approached industrial warfare. Rather than producing millions of identical machines, Ukraine was creating an ecosystem of complementary technologies, each optimized for specific missions. This required sophisticated manufacturing processes, skilled technical workforces, and supply chains calibrated to precision tolerances. It also required something else, a level of technological sophistication that most observers had not attributed to Ukraine before the war. More importantly, Ukrainian domestic production was becoming increasingly self-sufficient. Early in the war, Ukrainian drone manufacturers had relied on imported components from China, from European suppliers, from anywhere they could source electronics. This dependency had been a vulnerability. If Western countries restricted exports, or if Chinese suppliers cut off access to microchips, Ukraine's production could collapse. By 2025, this vulnerability was rapidly being eliminated. Virai announced in March 2025 that it had produced 1,000 drones entirely from domestically sourced components. Aerorozvidka refined the R-18 platform, creating an 8-rotor system capable of sophisticated long-range reconnaissance and strike missions using Ukrainian-manufactured processors and sensors. This domestic capability had profound implications. It meant Ukraine was no longer dependent on Western suppliers for continuity of operations. It meant Ukraine could sustain drone production regardless of sanctions or supply disruptions. It meant Ukraine had become genuinely autarkic in drone technology, a strategic advantage that no other nation fighting the conflict possessed. Russia had to import components through sanctions-busting channels. NATO countries had limited domestic drone production capacity. Only Ukraine had achieved the combination of high volume, domestic sourcing, and technological sophistication. Even more significantly, Ukraine's drone technology was attracting international attention at the highest levels. Western military leaders began explicitly acknowledging that Ukraine had become a drone superpower. Danish Prime Minister Mette Frederiksen commented in October 2025, "The only expert in the world when it comes to anti-drone capacities is Ukraine, because they fight Russian drones almost every day. We need to incorporate Ukrainian technology and innovation into our own rearmament." This represented a seismic shift in how Western establishments viewed Ukraine. No longer was Ukraine a nation to be defended. Ukraine had become a mentor, a teacher, a repository of military expertise that the most advanced militaries in the world desperately wanted to access. NATO members began negotiating joint drone production agreements with Ukraine. Britain announced plans to manufacture Ukrainian-designed interceptor drones domestically at facilities in Coventry and Wales. Romania initiated discussions on producing Ukrainian drones for NATO export, creating production capacity that could serve Poland, the Baltics, and Central Europe. The United States reportedly opened negotiations on transferring Ukrainian drone technology. with Pentagon officials visiting Kiev to examine Ukrainian factories and production methodologies. This represented a fundamental inversion of geopolitical power dynamics. A nation under siege, fighting for its survival, had become a center of technological innovation that Western military establishments sought to learn from and adopt. Ukraine's domestic defense industry, forged in wartime necessity, was becoming a competitive advantage in global defense markets. Ukrainian entrepreneurs who survived the war would emerge as globally recognized drone manufacturers, their expertise sought by governments worldwide. The human dimension of Ukraine's drone revolution was equally significant. Mikhailo Fedorov, Ukraine's 34-year-old digital transformation minister, implemented a revolutionary system to optimize drone operations through gamification. Drawing on behavioral psychology and game design principles, Fedorov created a scoring system that rewarded drone units based on the precision and effectiveness of their strikes. By adjusting algorithmic weights, increasing points for specific types of targets, Fedorov could incentivize behaviors that optimized tactical outcomes. When he increased point values for eliminated personnel, kill counts doubled within a month. When he boosted points for tank destruction, drone teams began coordinating multi-platform strikes that saturated target defenses. When he added bonuses for air defense system destruction, Ukrainian drone pilots started hunting Russian anti-aircraft positions with renewed aggression. The system was controversial. Some drone pilots and commanders rejected it as reducing combat to a video game, as diminishing the moral weight of taking human life. Yet the data showed it dramatically improved operational efficiency. In a nation struggling with morale challenges and personnel fatigue, after 3 years of continuous combat, the system provided psychological motivation alongside financial rewards. This represented something historically significant: the deliberate integration of game design principles into military operations. It reflected how thoroughly digital native Ukrainians understood that engagement, motivation, and optimization could be engineered through algorithmic systems. Fedorov had taken insights from the gaming industry, the psychology of achievement, progression systems, leaderboards, achievement badges, and applied them to warfare. It was simultaneously brilliant and unsettling, effective and morally ambiguous. Equally important was Ukraine's integration of artificial intelligence into drone operations. Ukrainian developers, including companies working with Palantir Technologies, created systems that could identify targets in thermal imagery automatically, navigate drones in GPS-denied environments using terrain mapping algorithms, enable single operators to control multiple drones in coordinated fashion through machine learning assistance, and adapt drone behavior in response to electronic warfare interference through real-time algorithm adjustment. By late 2025, Ukrainian engineers were working on the next frontier: autonomous drone swarms. Not single drones operating independently, but coordinated teams of dozens or hundreds of machines working in synchronized patterns, making collective decisions about target acquisition and engagement. These weren't fully autonomous. Human commanders still made the decisions about whether to engage, but the AI handled tactical coordination, target prioritization, flight path optimization, and threat avoidance. A single operator wearing a virtual reality interface could literally see through the eyes of a dozen drones simultaneously, make a single command decision, and watch as AI systems translated that decision into coordinated action across the entire swarm. The implications were staggering. A single operator could potentially control not one drone, but 5, 10, or theoretically even 100 autonomous platforms. The barrier to scaling drone warfare wasn't pilot availability. It was technological sophistication in autonomous systems. Ukraine had overcome that barrier. Ukraine's military understood that they were in a race against Russia and against technological capability itself. As Valery Zaluzhny noted in April 2025, it is obvious that victory on the battlefield now depends entirely on the ability to outpace the enemy in technological development. This realization had profound implications for military doctrine globally. The United States Army explicitly began rewriting battlefield tactics. In July 2025, U.S. Secretary of Defense Pete Hegseth issued a directive ordering every Army squad to be equipped with unmanned systems. By the end of 2026, the Army launched its first official drone course at Fort Rucker, Alabama, teaching soldiers to build, fly, repair, and operate drones in combat conditions. The curriculum included FPV drone, racing, literally having soldiers practice drone piloting through obstacle courses, because the Army recognized that the hand-eye coordination required for drone racing directly translated to combat effectiveness. The implications were sweeping. Infantry doctrine would fundamentally change. Soldiers would carry drones alongside rifles as standard equipment. Tank tactics would be redesigned to account for persistent drone surveillance. Air defense strategies would pivot toward countering unmanned threats rather than manned aircraft. The very concept of what constitutes a soldier would shift toward someone who was equally comfortable flying a drone as firing a rifle. All of these changes traced their conceptual origin to Ukraine's 3.5 years of drone warfare experience. Ukraine had become the proving ground for military innovations that would reshape how every military establishment on Earth conducted warfare. Yet the most profound implication was economic. The traditional military-industrial complex, built on platforms that cost hundreds of millions of dollars to develop and take decades to produce, faced fundamental disruption. FPV drones costing $500 could disable M1 Abrams tanks worth $10 million. The cost asymmetry was so extreme that it challenged fundamental assumptions about military economics. This raised uncomfortable questions for Western defense establishments. Did it make sense to build expensive tanks when inexpensive drones could disable them? Did fighter jets remain strategically viable? What did military superiority mean when a $500 machine could destroy a $500 million weapon system? Some military theorists began questioning whether the entire structure of military procurement needed to be reconsidered. Instead of building a handful of expensive platforms and hoping to protect them, should militaries instead pursue a swarm strategy? Thousands of inexpensive systems that could overwhelm defenses through sheer numbers? Ukraine, through Operation Spiderweb and the drone war that preceded it, had forced the world to confront these questions. And the answers were reshaping global military doctrine. The story of Operation Spiderweb is ultimately a story about the future. It's a demonstration of how modern warfare is being fundamentally transformed by the democratization of technology. It's a proof of concept that nations no longer need overwhelming industrial capacity or massive conventional militaries to project power. They need innovation. They need the ability to adapt faster than their adversaries. They need engineers willing to experiment, to fail, to iterate constantly. Ukraine proved this. A nation with a GDP smaller than many individual American cities, facing an aggressor with vastly greater resources, defeated through innovation what it could not defeat through conventional means. 3 patterns emerge from this story that will define the future of conflict. First, technology is becoming increasingly democratized. What cost billions to develop a decade ago now costs millions. What cost millions a decade ago now costs thousands. What cost thousands is now costing hundreds. This trend will continue. The barriers to entry for sophisticated warfare systems are collapsing. Small nations, even non-state actors with sufficient resources and technical knowledge, can develop capabilities previously reserved for superpowers. Second, the advantage lies not with the side that has the most weapons, but with the side that innovates fastest. Ukraine didn't win through attrition. It won through technological adaptation and strategic insight. The organizations that will dominate future conflicts will be those willing to experiment constantly, to embrace failure as data, to iterate at the speed of weeks rather than years. Third, the future of warfare is becoming increasingly autonomous, increasingly algorithmic, increasingly dependent on artificial intelligence. The drone pilots of today will be replaced by AI systems tomorrow. The targeting systems controlled by humans will give way to systems that identify and engage targets with minimal human intervention. This is not science fiction. This is already happening in Ukraine. Yet Operation Spiderweb also reveals something more profound about human nature. Shows that desperation married to ingenuity produces extraordinary results. When people face existential challenges, when their homes are being destroyed, when their nation's survival is at stake, they innovate at speeds that peacetime organizations cannot match. They take risks that conventional military hierarchies would prohibit. They dream bigger because they have nothing to lose. Ukraine's engineers weren't working within institutional constraints that demanded 5-year development timelines. They were working under fire, literally designing and building systems that would be used in combat within weeks. This urgency was a feature, not a bug. It forced rapid iteration. It eliminated bureaucratic overhead. It allowed brilliant ideas to be tested immediately and either discarded or refined. This has profound implications for how military organizations should be structured in the future. Perhaps the rigid hierarchy and slow procurement processes that characterize most Western militaries are liabilities in an age of rapid technological change. Perhaps the advantage lies with smaller, more adaptive, more experimental military organizations. Yet there's also a cautionary note embedded in Operation Spiderweb. It required intelligence. It required covert operatives inside Russia. It required the ability to maintain operational security despite facing an adversary with sophisticated signals intelligence and cyber warfare capabilities. Ukraine succeeded not just through innovation, but through strategic cleverness, through deception, through understanding the psychology of an overconfident adversary. The ultimate lesson of Operation Spiderweb is humility about what we think we know about warfare. Military theorists confidently predict the future. Defense contractors build expensive platforms based on those predictions. Generals structure forces around assumptions that feel certain. Then reality intervenes. A small expendable drone destroys a tank worth millions. AI identifies targets with greater accuracy than humans can achieve. Young engineers in basements invent capabilities that established military establishments thought impossible. Ukraine's drone war reminds us that warfare is not a predictable physics problem. It's a contest of human ingenuity, strategic insight, and technological adaptation. The side that understands this, that embraces uncertainty, that encourages experimentation, that rewards innovation, will dominate. Looking forward, several developments will shape the next phase of this conflict. Ukraine will continue accelerating domestic drone production. Plans announced in late 2025 project 2.5 million annual production. This would create a quantitative advantage in drones that Russia will struggle to match. AI integration will advance rapidly. Single operators controlling autonomous drone swarms represents the next frontier. This capability, perfected in Ukraine's ongoing conflict, will transform military doctrine globally. Long-range strike capability will continue expanding. Ukrainian drone ranges are increasing. By 2026, Ukraine may possess drone platforms capable of striking targets throughout European Russia and into Siberia. Russia will adapt. Electronic warfare systems will become more sophisticated. New air defense technologies will emerge. This is the nature of military competition. Each side develops countermeasures to the other's innovations, leading to perpetual escalation. Most significantly, Ukraine's drone revolution will be replicated. Every nation will invest in drone capabilities. Every military establishment will reorganize around unmanned systems. The genie is out of the bottle. The future is drone-enabled. Other nations will learn from Ukraine's example, adopting the lessons of wartime innovation. Operation Spiderweb occurred on June 1, 2025. It was a single night. 117 drones, 41 aircraft damaged or destroyed, thousands of kilometers behind enemy lines. A coordinated strike that was technically sophisticated, strategically brilliant, and tactically devastating. Yet it was also something more. It was a demonstration that modern warfare had fundamentally changed. It showed that nations no longer need overwhelming conventional advantages to project power. They need innovation. They need the courage to think differently. They need the ability to adapt faster than their adversaries. Ukraine showed the world that such capabilities can be developed under fire, by engineers working in conditions of existential pressure, through distributed networks of innovators rather than centralized military-industrial complexes. This is the future of conflict. Not massive tank formations, not strategic bombers dominating the sky, but small intelligent machines operated by people who understand that wars are won, not with more weapons, but with smarter weapons. Ukraine waited for Russia's drone power to reach its peak. They studied Russian doctrine. They documented Russian capabilities. They mapped Russian vulnerabilities. And then, when Russia believed it had achieved strategic advantage, Ukraine struck with precision that Russia could not defend against. The lesson is clear. In modern warfare, patience and innovation beat brute force. The future belongs to those willing to think differently, to build faster, and to adapt constantly. Ukraine has learned this lesson, and the world is watching.